Welcome to EDU World Space.
So to answer this question, we must first go over what we're given. So we're given that at x is equal to 13 millimeters, and the potential is equal to 230. So the potential at x, Vx, is equal to Cx 4 over to the power of 4 over 3. So now if we compute that and use a little bit of algebra, we're going to get that C, if you move this to the other side, so divide the whole equation by x to the power 4 over 3. So C is equal to the potential at x over x to the power of 4 over 3. And remember, we're given both these. So now if you just plug them in, so it's 230 over 0.013. Remember to compute it in standard units. So we're converting the 13 millimeters into meters, and this is to the power of 4 over 3. And now if you plug this straight into our calculator, we're going to get that is equal to 7,523. I'm just reading it off straight in my calculator. 3.6.7, let's round it off, volts per meter to the power of 4 over 3. Yeah. So now this is part A. So now moving on to part B. So the potential at Vx is equal to, once again, the same formula for, let me write that, yeah, that's decent, 4 over 3. So now if we differentiate both sides, we're going to get that dV with respect to x, of course, dV over dx is equal to, now if you differentiate this, we're going to get that, so we need to move the power to this, power to the coefficient side, x, and now we got to take 1 off this, so it's just going to be 1 over 3. And now, using the chain rule, we also need to multiply it by c. So now we're going to get the formula. This is equal to the potential at x. So this is just the formula for potential, is equal to negative c 4 over 3 times x to the power of 1/3. And this is the answer for the second part. Let me write that a little bit better. So this is x. So straight from this, we're just rewriting it. So we get a better understanding of the answer and what they're looking for. So this is the answer to part B. And now moving on to part C, we can use the formula that force is equal to the charge times the electric field strength. So now we know that the EX is equal to the following up here. So now if we, so let's actually first compute that. So let's bring this over here. Let me get the 1, 2. So if you bring that here, yeah, let me just erase this. Remember, this is equal to E here, and this is 1/3. So now if you compute this with the constants that we have, so we have C, which we just calculated up here, and we have X, which was given to us, which is 13 millimeters. So I don't think I need to write out the complete the formula with all the constants in, but if you just compute this straight from our calculator, we're going to get that the electric field at X is equal to -18723.2. So now if you put this into our force equation that we used up here, force is equal to charge times EX. So this is, the charge is -1.6 times 10⁻19. of an electron times negative 18723.2. And if you compute this into our calculator, we're going to get that the force is equal to 2.99 times 10 to the negative 15 newtons. Always remember the units. And that's the force acting upon the electron. And there we go. Thank you for listening.